Hi everyone. So the goal of this video is to understand net force. I want you to be able to explain net force, calculate net force, and draw free body diagrams. So as usual, before we start, try to find a good spot in the classroom or wherever you are so you can focus on the video. Make sure you have a copy of the guided notes, and the use of headphones is suggested. One final tip I'll give for you is if I am talking too fast, you can always slow down the video. If you're watching this on YouTube, there should be a settings button where you can change the playback speed. So if you want to slow it down, maybe try 0.75. But if you want to speed it up, you can try 1.25. If I am talking too slow or if you just want to move through it faster. All right, so what is net force? Net force is the total force acting on an object. So if you were successful in your last unit and you understand force, this is kind of like the next step. We talked about one force and we talked about one force pushing on an object. But if we want to understand net force, we need to think about, okay, well, what if you have more than one force acting on the object? And that's pretty typical for most of the objects in our everyday life. A lot of them have more than one force acting on them. So all we do is we just add up all the forces, and you might see some funny symbols or some funny terms. I'm just going to point out some that you can see right here. So there's this funny symbol for sum. So this basically just means like the sum of all the forces. This is kind of like a mathematical um, little symbol that you might see in math, but you also see it in physics. So basically this is the sum of all the forces. You also might see something like this that says F net. Sometimes when we talk about forces, we'll say capital F for force, and then we'll put like what kind of force are we dealing with? In this case, we're being specific and saying we're trying to find the net force. So we put a little net right here so people know that we're talking about net force. And then we might put numbers or we might put something else here to let someone know that we're talking about a force, but we're talking about like a specific force. So this might be the first force that acts on an object. This might be the second force acting on an object, and so on. All right, so these little symbols down here just tell you what specific force you're dealing with. All right, so the next topic is balanced and unbalanced forces. So when we have a balanced force or balanced forces, that means that our net force is zero. You can think about an object being pushed on both sides with equal and opposite forces, then the net force is zero. So the object is not accelerating. It could be at rest or it could have a constant velocity. The key here is that it's not accelerating. And so here's just an example of that. If you have a tug of war and each team is pulling with the same amount of force, well, then your net force is zero. You have 300 in the negative direction, you have 300 in the positive direction, and so the total force or the net force would be zero. Now, on the other hand, you can have unbalanced forces where the net force is not zero. All right, and that means that the object is accelerating. It can be slowing down or speeding up. The key here is that the velocity is changing. And the net force and the acceleration are in the same direction. And just a little diagram of that. So that'd be like one team pulling with way more force than the other team. They're going to start to kind of build up some momentum and they're going to be able to pull that rope away from the other team. All right, so a free body diagram kind of looks like this. So what we usually do for a free body diagram is we draw a box, and we do this sometimes no matter what the object is, just to simplify our drawing. So a box is just an easy way to kind of draw whatever object we're dealing with. And then we want to draw arrows for all forces acting on the object. So in this case, there might be 4 forces acting on the object, and we draw arrows to show which way that force is, being directed. And like we talked about last time with vectors, the length of the arrow kind of tells you how much force it has. And obviously in this picture we have numbers as well, but you can see the numbers kind of line up with the length of the vector. If necessary, we can find the net force. So if we're asked to find the net force, we add up all the forces in the horizontal direction, and then we would add up all the forces in the vertical direction. So really quickly, you might be able to test yourself and pause the video to see if you can figure out the net force. So if you pause the video, you might have done something where you have 20 in the positive direction, but you have 3 in the negative direction. So you should do 20 minus 3 to get a net force of 17 to the right. All right, and then for the vertical direction, you would do 6, and then you would do 6, but it'd be 6 minus 6, right? Because this one is negative because it's heading in the negative direction. And 6 minus 6 is 0. So this one has no net force in the vertical direction, but it does have a net force in the horizontal direction. I'm going to try to draw a couple of examples here. So let's try to draw a few free body diagrams, and let's see if this works. So just to give you some examples, an object is being pushed to the right with a force of 40 newtons. So I would draw a box, all right, and then I would just draw one arrow. I only have one force in this problem acting on the box. This might be a simplified example, but this is kind of what it would look like. So that's all I really have to draw for my free body diagram. If I wanted to, I could say that the force is 40 newtons. So I could just say like 40. Oh man, I'm not drawing very well, but I never was a good artist. All right, but that's pretty much it. That would be my free body diagram for this example. All right, so for my next example, I have Dr. Longyear pushes an object with a force of 80 newtons, but Amir is pushing to the left with a force of 60 newtons, and Gur is pushing to the left with a force of 50 newtons. All right, so what I'm going to try to do here is I'm going to try to draw this. So we're assuming that I'm pushing to the right. All right, so I'm just going to draw a box. All right, and then my arrow over here for me might be like this. I don't know, I'm going to try to make it the biggest arrow here because my 80 newtons is bigger than both Amir and Gur. But I might draw Amir's arrow like this, something like that. All right, and then I might draw Gur's arrow maybe like this. Okay, so that would be a free body diagram for these three forces. I have 80 in the positive direction, but then I have a 60 in the negative and then a 50 in the negative. All right, and then really quickly, if you wanted to, you could try to find the net force, and maybe I'll leave that as a challenge for you to try to figure out. But remember, you want to just add up all the forces, remembering that the ones to the left are negative. All right, we'll try one more here. An object is being pushed 30 newtons north, 60 newtons east, 30 newtons south, 20 newtons west. Draw the free body diagram and find the net force. So there's a lot of forces acting on this object, but let's not get too worried about that. Let's just draw each one of them one at a time. So we'll start with 30 newtons north. All right, then we'll do 60 newtons east. Okay, and then we'll do 30 newtons south, and then we'll do 20 newtons west. So as you might see, our object is going to be accelerating to the right. All right, these two, I have 30 newtons south and I have 30 newtons north. Those two are going to cancel out, or the net force in the vertical direction is going to be 0, because 30 minus 30 is 0. Now, on the other hand, for the horizontal direction, I have a 60 in the positive direction, but then I have a 20 in the negative direction. All right, so for my net force, I would do 60 minus 20. Maybe I'll write that here if I can write it in this scribble. So it'd be like 60 minus 20. And so my net force would be 40. So I would say my net force is 40 newtons in the horizontal direction. All right, so there's just a few examples on how to draw a free body diagram and how to find the net force. All right, you probably have some practice problems to do with those two skills, so good luck.